Hello, everyone. Welcome. Thank you so much for joining us today. While we let everybody trickle in, we'll go through some quick introductions and then we'll get started. My name is Kayla. I'm here representing the Acelab team. We have Cass and Jason here from MGM. Before I pass it over to them, I want to quickly take us over to Acelab. So in just a moment, you should be able to see my screen here. But if you're not familiar with Acelab, a great place to start whenever you're looking to do some research is using the search bar at the top of the screen. In this case, you can search MGM or Alumicor to find their page. Just make sure you're toggled over to the manufacturers when you're doing that. But however, when we're on the page, we've got some really great information for you here. Lots of information to explore. We've got your products. You can click into any one of these pages here to get more information. You can also click right here to actually save one of these products to your firm library as well. So feel free to do that if you're looking to have that product there for future reference or in future projects. Yeah, there's lots of great information here. So I will go ahead and send you all the link to this page in just a moment in the chat so you can have that to reference. A couple other things to make note of. We will be doing Q&A at the end of the presentation. So if you have any questions that come up throughout the presentation, feel free to go ahead and drop that in the Q&A button at the bottom of your screen. We will get to as many as we can at the end. We will also have a poll that will pop up on your screen as well. That there is an optional poll. If you're not interested in getting any kind of follow-up emails or anything, you can just X out of the poll and we won't bug you. However, if you are interested in getting connected with Cass and Jason after the webinar today, fill out the poll. Feel free to specify any specific project or questions and what information you're looking to get from them. We will connect you via a conversation in Acelab, so you'll get an email notification when that conversation is open, and you can respond directly to that email, or you can log into your Acelab account and respond and communicate directly with Cass and Jason there. Couple other things to make note of. This is an AIA-approved presentation, so we actually already collected your AIA numbers, but if you're worried we didn't get your number, you can just fill out the form that I'm going to drop in the chat, and that way we'll ensure that you get credit for this presentation. And yeah, that is actually pretty much everything from my end. So with that being said, I will go ahead and pass it over to Cass and Jason.
Thank you, Kayla. Okay. Everybody see the screen good before I get going?
Yes.
Excellent. Okay. Good stuff. So my name is Cass Dvorak. I work with Alumicor. I am the CDM of Atlantic Canada. And we work very closely with our distributors, MGM, who Jason is a representative of. He is the project manager at MGM Architectural Glass and Aluminum. And we have been working together for a few years now in partnership. And we have put this presentation together to educate. And let's get into it here. We'll get into some of the objectives of the presentation here. So really, we're going to be looking at how the window wall systems are going to offer you guys cost-effective alternatives to traditional curtain wall construction. We're going to look at the floor-to-floor glazing solutions and why this is advantageous to you guys and potentially to all the trades involved in the project. In the course, we're going to complete the process. We're going to look at the beginning of the extrusion process right from the start. We're going to look at how it's fabricated, how it's manufactured, all the different processes, finishing options. And then we're going to look at delivery to site and installation instructions, and just generally speaking, giving you guys a nice general knowledge base on modern window wall systems so that you understand what these systems should bring to the table when they're presented to you guys. So let's have a look at that. These are the learning objectives for today. So right off the bat here, compare installation methods and benefits. We're going to allow Jason to do that when we get to that part of the presentation, but we feel that's very advantageous to the group here to see just basically what the options are in terms of how these are going to get installed onto the slabs. We're going to look at how the systems manage water, how it relates to kind of some of the other modern facade systems, and how we achieve and how that is achieved in these systems. Structural deflection accommodation methods, window wall in the past, and we will get into this later, has been problematic because of deflection accommodation traditionally. So there's been a number of advancements in this area as well that have really allowed these problems to not really be a mainstay of the systems themselves. And finally, we're going to analyze thermal performance strategies. We're going to look at what drives those thermal performances, how our window walls and some of the other window walls in the modern sense are going to be reacting, and how they can start really comparing to curtain wall and the high-end aluminum systems that are out there that you are likely used to designing with. Just a little roadmap here so you guys understand where we're going in the next 45 minutes or so. We're going to look at a very easy definition of what is window wall. We find, Jason and I, when we present, one of the first things that everybody wants to know right off the bat, and when I'm dealing with architects, is they're not even sure what window wall is, like the actual what separates from curtain wall. So we're going to look at that. Again, we're going to look at procuring, handling, fabrication, installation. We're going to go through all the phases of the product itself, how it deals with deflection, water performance, advantages, and then at the very end, we're going to give you guys, after the educational part of the presentation, Jason and I are going to take 5 minutes of your time and give you just a little bit of a background of our relationship between the companies and what we're offering the groups that choose to work with our modern version of window wall systems. So just one moment. Excuse me. Okay, so right off the bat here, what is window wall? So the best way to define window wall, and I did go to all of the leaders in my own company here, the best way to define window wall is a slab-to-slab application that sits inside the building. So that is the big difference between curtain wall. Typically, curtain wall will sit on the outside of the facade, and window wall is going to go from the top of the slab to the bottom of the slab and sit on the inside, and usually span for most of that level of the building. And why are we going to use it? Why is it coming up all the time? Why are there groups that are wanting to use window wall? Well, the reduced sound transmission between the floors is really one of the biggest selling points. Because the aluminum's not moving past the floors, there's not going to be any sound transmission like there would be with a curtain wall that would move past the slab. The sound's going to stop at the slab. That's a big selling feature for mixed designs, residential, and what have you, where residents might be worried about that. It's installed from the inside of the building. So just briefly, in our region, and our regions may be a bit specific, but we were just granted the ability to go up another 10 stories in the city for building permits. So obviously every building is now being redesigned to go up further. And this benefits people that are using window wall, as the cost of equipment and the difficulty and complexity of the job as you're on the outside of the building as it's going up obviously get worse as it goes up. So being able to stay on the inside of the building is a huge advantage, not only for just a simplicity, but also cost savings. And Jason, I always encourage my colleague Jason to cut me off if I'm forgetting something, and he will be doing that throughout the presentation. So you let me know, Jay, if I'm forgetting something. But yeah, and another huge advantage, just like a unitized curtain wall system, and we'll get into this, it's prefabricated in the plant, which means more quality control. You're controlling your environment, and these are all advantageous to contractors and engineers. We'll get into the anchored receptor system, but the receptor system ultimately allows for most of the building deflection. Some of the gaskets we use as well, but you'll see what I'm talking about there. Also, it's very energy effective. It's cost effective. The partners that Jason and I have been working with have done a lot of work to get the costs to the area that we believe people want to see them. Like, so on a project base, when you're trying to relate cost savings, and it's usually cost versus performance, right? We feel that the modern window wall systems have found a way to kind of harmonize those two ideas in a really positive way. So let's start here, right at the start. This is what it's going to look like before it looks like anything else. It's going to start as an aluminum log. It's going to get cut down into shorter billets. All these pictures have been taken from our facilities in the United States, but just to give you guys an idea, if you haven't seen the process, that on the left side here, we have the dies. These billets are going to get heated up to extreme heats. They're going to get pushed through the die. They're going to come out to about 100 feet, depending on the complexity and the size of the die. And that's essentially where they're going to start. And then from there, we're going to send them, or typically they'll be sent over to a finishing facility. This is an anodizing facility specifically, but window wall is typically able to be painted and powder coated, whatever really is needed. But typically we see anodizing, right, Jay? Typically anodizing. Yeah. So this is just a brief look at the anodizing process here. It's a naturally occurring electrochemical process. They have to be scrubbed and rinsed in an acid bath. And again, we actually have another presentation all about this. So I kind of borrowed some of the slides from this just to explain some of this stuff. But the decorative, durable, corrosion resistant feature, it's very ideal, especially for, we're on the coast, so it's really ideal for us. But really, anywhere you go, it seems like anodized is still typically the main finishing idea or solution for window wall. Then it's going to get into handling. We got to send it around, send it to different facilities. I'm sure every place will. They're going to package them up nicely so they don't get scratched, send it off. And this is where it starts getting a little bit different than curtain wall as it hits the facilities. These pictures were taken from inside MGM's plant, but typically you're hitting a manufacturing line now. And as you can see, these units now are going to be pre-glazed in-house. And that is a big difference. Some unitized systems will be pre-glazed in-house, but that's a big difference that drives the window wall systems. And what that does is it presents a couple different opportunities for whoever's working with it to find some solutions. And essentially what that does, and the difference is you have to find room for curing and storage, and those are the big differences. So once they're glazed, they need to be set aside, they need to be untouched for, what is it, Jay, about 2 to 4 days, depending on the type of caulking you're using. Yep. So they're gonna be set aside. And then not just that, but for anybody who's ever picked up a frame with glass in it, they've now, with being pre-glazed, have probably become about 400 to 800 pounds, depending on the module size, which requires its own new type of logistical handling. Again, different from curtain wall that way. And this is really, I'm trying to show the differences of window wall and curtain wall, because that seems to be where most people get confused. So these are going to be a completely pre-glazed and prefabricated module before it goes to site, as you can see here on the tables. And just to show you, they're going to be stacked like that horizontally, needs to be horizontally, and they're going to cure for a few days. Again, if you use the right SSG product, you can speed that time up and really speed yourself up on site, depending on what the requirements are. That can be discussed with the contractor for any modern window wall system. And transportation has to be considered. It is a bit different of a site schedule for this. Typically with a curtain wall 6 system, a lot of it's going to be fabricated on site. It's going to be prepped in the shop and sent to site to be fabricated, to be pieced together on site. What you're seeing now with window wall is fully fabricated modules being brought to site. This is a local site where we installed a version of our modern window wall as well. It's going to show up on a skid. You're going to have to, or the GCs, the site project managers are going to have ways to quickly put these up on the stories. But essentially, the window wall installation is going to follow the building construction vertically, and you can essentially go up before they're done the building. So usually it's just a quick coordination with other trades on site to get your product up on top. But once it's there, it's a very quick installation, and that is really where we start seeing advantages to the window wall. Just a quick shot of telehandler bringing up, and next, that's a floor of window wall modules right there. Probably 2,000 pounds. So again, there's a couple considerations that need to be taken, but once you're in gear, I would say an entire floor could be installed in a day. Correct me if I'm wrong there, Jason.
Yeah, depending on the complexity of the job,
Yeah, right on. So I'm going to pass it over to Jason for this. This was one of MGM's sites that we visited frequently and worked very closely together with, and he's going to explain installing the receptors, and then we are going to move on to the slide, but he's going to start with this one. Go ahead, Jay.
Yeah, so what you're seeing here is a receptor system, is a sill receptor being installed on top of a curb. We have a curb in this application because there's a patio frame and they had to pour a concrete curb. So we're running along a whole curb, but there's a lot of times where you can be right on the very edge of the slab and you can mount right down to the slab. But this part here, the main key point on this is to make sure when you're laying this receptor down that you have all your beds of caulking laid in place and everything's sealed. It then gets bolted down into the curb, whether it's concrete or wood, whatever your substrate is. You seal off all your penetrants, all your miters and all that stuff. There's like it's like a silicone sealant. It's like a roll of silicone sheet that you lay down. You lay silicone over top of that. So that's your critical component right there for keeping water out of it. And so you just fully seal that whole receptor frame. And then all your modules just go into it and they stack.
Side by side, correct?
Correct, yeah, in a linear fashion, yeah.
Yeah, so essentially the modules just get entered in and then tipped up. I think we have a slide that shows that, so we'll get into it.
Yeah.
Next slide is good, Jay?
Yep.
All right. I am going to let you explain this one as well, because this is definitely more in your wheelhouse.
So there's several different anchoring types that you can do. This one here shows a strap anchor. So there's a groove inside of the head and sill receptor that you can preload all your receptor frames with. And you can bolt that right into the concrete from the outside, so you don't have penetrance right in your sill pan. And then you can actually space those out, coordinate as per the engineer specification. So you can put 2 per foot, 4 per foot, or you can just go 1 per foot, however the engineer decides. And then there's 2 different other applications you can mount them with. But this one here just shows you the strap anchor and how it goes.
Yeah, and we'll look at those other applications. I'd say the strap anchor is probably one of the more, on a bigger job, where, because the anchors, even when we're talking about managing deflection, the strap anchor can take some of that deflection as well, maybe if it's side to side. But let's look at the next one.
Yeah, horizontal fashion, yeah.
So Jason, this is the channel receptor, yep, or the channel.
Yeah, you basically have the same thing here, but it's a channel receptor, so that gets mounted down on the concrete slab, and then your sill receptor straddles right over top of that. Then you have no penetrance in your sill there either.
And obviously just a simple through bolt anchoring at the bottom for a smaller application if you're not as worried about building deflection.
Correct. If you have multiple, or if you have like a concrete slab that's not quite even all the way through, that's typically your best bet, because then you can shim accordingly as you go through.
Excellent. And again, as you guys see, the channel anchor here, I'm not sure if you can see my mouse moving on the screen, can you? Yeah. So the channel anchor, yeah, excellent. So the channel anchor here just fits into the slot, and that can handle a little bit of up and down deflection. And even side to side with it being sitting in the channel. There's no break on that or going horizontally. So installation here again, just as you can see here, I'm going to let Jason get into this, but I'm just going to explain the picture that we're showing here. So really the most important thing to understand is that you're going to have a head and a sill receptor, as you can see there. The sill receptor on the bottom and the head receptor. And then what's going to happen is once that channel is laid, the modules are just going to stack in, and they're going to put into the bottom and then lean up. And that's basically what we're explaining here. And then as they're leaned up, there's a drive-on head receptor here. It's just got these shark teeth, and you hammer it in, and that holds everything together after it's set in. So it really allows you to get that strip window feel, but essentially slab to slab, right? Mm-hmm. Anything to add to that, Jason?
Yeah, and so then you can preload your head receptors as well with the wind load clips. So they're inside of the receptor. Cash, you might be able to put your mouse on it to show.
Yep.
Yeah. The
right
wind load clips, the larger, bulkier one towards the back, right above the screw chases. Yeah, so there's a big block there. It's a big aluminum milled out block, and they can get preloaded into your head receptor too. So again, requirements on the engineering side of things. If you're faced with strong wind loads, a lot of movement, we can preload those. And so basically you have 2 window wall sections, and they're open back module systems. So when you put your first piece in, you can slide one of those wind load clips into that receptor, into that section. And then when you go to put your next section in, slide it into it, it just locks everything all in.
And so I think this is a feature. Oh, sorry, go on, Jay. My bad.
Yeah, sorry. So that drive-on piece there would be no way that could back off.
Excellent. And yeah, and this is I think this is what you should be looking for on a modern window wall system is the type of ceiling like this, using a gasket built ceiling, and we'll get again coming up to that and why that's so important. But to stay on the vein of installation here, what do we do at the slab edge? And that is a good question, and that is another thing that separates, I would say, window wall from a punched window system or a ribbon wall system, or a curtain wall for that matter. What we're going to have here is a slab edge cover essentially, and this is part of the receptor. This is a rolled component part of the receptor, and it just comes down and hangs over the slab. And this is a part of the head receptor, so sill receptor, head receptor, from covering the slab. And then from there, what we do in-house is we have an option for a slab, just an aluminum slab cover essentially. But there are options to install ACM paneling, I believe, spandrel glass, as you can see in the example given here at MGM's job site. And any modern window wall system is going to allow this, and it should be really allowing for any kind of filler product to be used over top of the slab. But that is how the slab is handled, as you can see here. Moving up, the spandrel glass is going to be installed, and then you're just going to move up on the frame. Anything to add to that, Jason?
No.
Okay, right on. So yeah, we're going to look at how these modern window wall systems are going to allow for deflection. Now, typically speaking, back in the day, when window wall first became a thing, the horror stories that I heard from it was that essentially they were only sealed using caulking, wet seal. And that obviously, especially on the larger buildings, as they move and deflect, and not even over a lot of time, that obviously caused leaks. So what the modern systems have gone and done is essentially move to an entire gasketed system, so that can handle the system itself can move and adjust, and the gaskets can handle the movement without breaking the sealing and the caulking. As you can see here, we're just pointing to all of the gaskets that have been added to the system, where maybe traditionally they would have been a wet seal. However, live load deflection is mostly handled at the head receptor. That's where you're going to leave most of your tolerance for construction. As you can see in here, there's a lot of room left in this cavity. Anything to add to that, Jason?
Yeah, they leave a 3/4 inch space between the top of your frame module and to the inside of your receptor. So each floor has 3/4 of an inch of movement available there, either way.
Along with whatever tolerance is granted in the anchoring system.
Yeah, so your story creep and your concrete shrinkage over time, should never exceed that amount.
Excellent. And then to look at, so that's vertical deflection, but horizontal deflection we've also had to take into account. So we're looking at our system here just as an example, which is an SSG system. But typically in the system, what we've done here is a vertical diverter gasket. So this is a very heavy duty proprietary gasket that sits between the modules, and it almost essentially acts as a curtain wall throat almost. But as you can see, it can be used in a couple different applications there, and even it can be capped to mimic that look. But ideally speaking, this example is an SSG, and as you can see, that gasket is just a big rubber, high quality rubber chunk. And as that system deflects horizontally, that vertical gasket is going to absorb that deflection between each module as well. Jason, do you want to speak to this a little bit? It's just talking about deflection being handled in the strap anchor system and in the channel system, going along with what we discussed earlier. I don't know if there's much more to say about that.
Yeah, not too much, but I guess there's another point too that we can kind of touch on since the details here. But your anchoring is going to be determined by how far your system has to stick out past your slab. So the front bull nose of a floor slab has an insulation. You can see it's in the gray there. Typically, you see about a 1 inch thick insulation. So you want your window system to come out past that. And so you can't really drill a concrete bolt any less than 2 inches away from the front edge of the curb. So depending on how far the system comes out, like the illustration on top, if they call up for 2 inches of insulation, that's going to put our bolt too close to the front edge. So in that case, we might look at switching over to a strap anchor, which actually pushes that anchor bolt back further on the slab.
Yeah,
but
so that's a great point.
Yeah, so in terms of the deflection on it, as we kind of alluded to earlier, that system can move in a linear fashion if it needs to be over time. Thermal expansion and the movement of the building, it absorbs it vertically and horizontally.
And that's such a great point to add, Jason, just in terms of, I think a typical modern window wall system is going to want to give you options on how it can be installed, how it can be mounted, because every project's different, right? We always have our standard details, but everybody in this presentation knows that every project's going to have an anomaly. It's always going to have a detail that doesn't make sense. And really, ideally speaking, I think a modern window wall system should allow designers the tools to get around these types of things.
Yes.
So we're going to look at one of the main advantages of this. So I touched on this earlier, but really And especially in the bigger markets, in the bigger markets with the taller buildings, this is an effective installation system because of what you're seeing in this picture. The building schedule allows that product can be installed following the installation of the vertical stories going upwards. And just one moment. Sorry. And for specifically highly repetitive projects, that is where this is where our window wall system is also going to be your best friend. Something that it can be repeated in-house. You can take advantage of the in-house quality, the in-house control. Typically speaking, I think most, well, maybe not. It's a good point that typical details and repeated details are always faster and easier to quality control when you're fabricating in-house. So when you're dealing with a system like this, the more typical details, the better, as really what you're doing is you're just speeding up fabrication. And as it goes to site, it can just follow that building. So if it really does change the schedule of the building installation, it can speed it up, but the people that are on the project management team are going to have to be aware that this is the product being used, because it's going to require the glazing contractor to be on site at a different schedule, right, Jay?
Correct.
And as it's being installed from the inside of the building, you can see there's not a lot of construction equipment on this site. You don't see swing stages. You don't really see any like construction elevators going up on the skirt of the building. This is mostly being done from the inside, and that in the right application is, especially in a city like Halifax that has tight streets and it can be very difficult. It's very advantageous.
Yes.
So now we're going to look at how to keep the water out. That is the big question with window wall. These systems used to leak. Why don't they anymore? So essentially we touched on it with regards to the prime seals versus the gaskets. Old seals only relied on prime seals. So that is really primarily where you saw the leaks. But how do you implement a gasket system that actually stops the leaks? And we're going to look at that. But really what you want to do is implement the rain screen principle. So it's the same principle. It's a rain screen design that's going to be present on any high-end curtain wall system, on any high-end ribbon window system. Really, any high-end building facade system in 2025 should have a rain screen principle, a rain screen system that's built in. But essentially what I mean by that is it's the idea that you keep a cavity between the outside and the inside of the building with an internal seal separating the pressure, and then the pressure in the cavity will match the outside pressure. So any water that manages to get into a window wall system should effectively be wept out the bottom, and we'll show you what that looks like. But it is the same principle as a curtain wall weeping system. So as you see here, the pressure cavity remains, the seal is on the inside, nothing's going to get through. The water is essentially just, if it makes it in, and water is always going to work its way into this area of the system, but as it makes its way in, it's just going to wind up here and filter out the weep hole. This is a weeping cell baffle, just to make sure debris doesn't get into that hole and plug it up. And you see the same thing going on at the bottom here. Anything to add to this, Jay? And also here at the slab.
No, I think it's pretty good.
Yeah.
If anything behind your slab edge cover, it also weeps out through the top of the head receptor as well.
Yeah. So the system is really, I think the issue of water penetration has largely been solved in modern curtain wall systems. And for the most part, I think in the last 5-10 years, it has been solved in modern window wall systems as well. And this is how. It's essentially the same idea. It's just trying to find a way to implement the same principles with a slightly different build system, right?
Right.
Then we'll look at thermal performance. So this is becoming really important in Canada. Our building codes just changed, I think, 3 months ago. And we've actually been dealing with this with window wall already, and that in a positive way. People are now looking for high performance thermal systems. So the old systems, anything that was being primarily used even 30 years ago, especially in certain markets in Canada, are, I wouldn't say they're getting phased out, but what's happening is that they're becoming more strict on how they're allowed to be used. And what I mean by that is the system itself is usually as good as its infill, but it still needs to have a tight rating. So window wall systems now need to be if a window wall system isn't hitting the same thermal performance standards as a curtain wall system, a high-end curtain wall system, I would say that any market, at least north of the American border, is going to be tough. So these are important things for people like Jason and I, because we have to deal with this all the time. So what are the factors that are going to affect that? On commercial buildings, it's largely what's happening inside the building. So that's got to be looked at. Is it residents? Are there going to be people cooking inside? Are there machines operating inside? What's going on inside this building needs to be considered and needs to be given potentially on the size of the project to one of our engineers or an engineer, so that can be worked out. Make sure that there's no issues. Adjacent construction details. You know, you never know what type of product, if there's another type of product being used in the project, all of that stuff needs to be considered. But most window wall systems should be, modern window wall systems should be able to integrate new products. That is another extremely important feature of these systems, as you all know. So let's look at how these new systems are performing. So a new modern, I would say a modern window wall system should be performing with a double glazed application up to about 0.3. That is about where the most strict Canadian construction codes are putting thermal performance, and that keeps designers away from having to design with a triple glaze in mind, because on a 40, 50, 60 story building, the costs on a triple story building can become exorbitant. So what you're trying to do is still hit all of the thermal benchmarks you need to hit while keeping costs under control. And this is how we do it. And it's essentially a very similar way to how we do it with curtain wall. This is how it should be done, is a strutted thermal break, polyamide thermal break. I think there are still a few systems out there that are pour into bridge thermal break. There are probably a few systems out there that aren't thermally broken, or with a very old foam receptor thermal break, similar to some of the old curtain wall systems. But ideally speaking, the thermal break is going to be in the receptor system. So this receptor base is two pieces, and they're rolled together using these polyamide strutted thermal breaks. And a polyamide strutted thermal break is essentially really what all of the high-end facade systems are using is a poly. I mean, you can get a little bit crazier and go with fiberglass or something like that, but that's not necessary yet in any of these climates. So, but really to hit these building code standards, typically speaking, you're going to need a dual strutted thermal barrier at the very least to meet thermal codes. Potentially the ability to go to triple glazed if necessary, or just a good understanding of what your system's going to need for an infill to hit, or infill meaning glass or ACM, to hit the codes that you're trying to hit in your region. That all must be considered. However, any new window wall system should be hitting 0.3. We're saying 0.33 here, but after running our own calculations on what we can hit with dual glaze, I'm quite confident saying a high-end modern window wall system should be hitting a 0.3 U value, whereas most high-end curtain wall systems are probably going to hit about a 0.26. Would you say, Jason?
Best case, yes. For a
Best
double glaze.
case, yeah. So again, there's ways to improve that. There are improved glass fillers, obviously. No glass, you could use panel fillers. Those are always a little bit more thermally sound than anything else that you can see through. But essentially, these systems, they should be able to meet standards for your region. So you should have a good understanding of what your region demands, and any modern window wall system is going to need to meet those standards so that really any infill can be used that's not too out of line. But yeah, just looking at the advantages of the newer systems that are coming out, the biggest advantage that we found that people react to the best are the cost savings. And essentially where you're going to see the cost savings aren't necessarily on the material. You're going to see the cost savings. The owner of the building is going to see the cost savings on the ability to install from the inside of the structure. They're going to see the cost savings as the building becomes larger, and they're going to see the cost savings when the design is kept to a repetitive design. So these are all factors when designing with window wall that should be taken into consideration. I think it's a natural reaction to want to get very design centered and everything. But if there are ways to design in the design stage that are going to save potentially millions of dollars, which some of these could, then I'd say these window wall systems actually offer potentially more solutions and more what's the word? I guess solutions is the word I'm looking for. More solutions for the issues that you're running into these more and more these days. 2025, I know in our region, we're running into labor problems in the city. We're running into difficulty finding large crews. And this is a very friendly system for that because of these reasons. They're quick on site. They're installed from the inside of the building. And most of your work is being done in-house in a controlled environment. You don't need a large crew in-house to do this type of thing. So these systems are getting much better to work with and much more advantageous for groups to work with and less risky. That's probably the most important part, is they are performing and behaving much more like a robust curtain wall system now. Just gonna show you guys a couple of just examples of some of the work that we've done and just put in here. This is a window wall system sitting outside the slab here that just part of the building was done in window wall. The rest of it was done in a curtain wall. So you just see the vertical structure going up and the slab edge covers over top. This is a job that we did last year here locally. And this is some of the work that we've done with this in the United States through Tube Light. That's Alumicor is a part of the Tube Light group. It's just to give you guys an idea of some of the different applications it could be used in. So that does conclude the educational portion of the presentation. Keep your questions just for one more second. I am going to get into the final part of this and just give you guys an idea of who we are, and we'll keep it brief, don't worry. And then you guys can pick our brains and ask us as many technical questions as you'd like. So I just want to make a brief introduction of the partnership between MGM and Alumicor. We've been partners for a few years here in Halifax now. Once upon a time, Alumicor had a plant here, and we don't anymore. And MGM then built a plant and took over distribution. Jason actually used to work for Alumicor and Tube Light once upon a time. So that's why he's so knowledgeable about our systems. And we worked together actually at the time. So it is a symbiotic relationship. And what we've tried to do as a group and as a partnership is offer to our customers, but more importantly to you guys, to the design community, the access to MGM and Alumicor's and Tube Light's engineering and design resources. That is where MGM and Alumicor have put most of their resources, I think, and they've put a heavy emphasis on assisting the design community. And I think that's what sets Alumicor as a supplier apart from the other suppliers in Canada and Tube Light in the United States, is their dedication to at least to the engineering side. And I think that's very advantageous to the group that we're speaking to right now, because typically we start with questions and we really are just trying to help people with their projects. We're just, if they ask us what we bring to the table, we'll tell them our products and stuff. But a lot of the times we just get questions on how to install, how to do this. And our philosophy as a partnership has been bringing that service to a smaller market in Nova Scotia and potentially into larger markets in North America. I think there's a gap in the industry right now for this level of service between the glazer and the supplier, where we can offer that level of detailed communication and really day-to-day support on a project. That's what we do for our local architects, and that's what we're prepared to do moving forward. And that's just our services here: architectural design, project management, sustainable solutions. I know MGM has a multitude of different ways they're willing to support the projects, whether it's consultation on site. Some of their customers do their own installation. They send consultants down to work with it. Other companies, crews. Alumicor has sent engineers to MGM to research and develop our own window wall systems and engineer those systems and make them the leaders of our window wall in Canada, essentially. And I think that we've taken great strides to do that on the eastern side of Canada. And of course, everything always being sustainable, always trying to make sure that anything that's being asked of us or anything that's required by the design teams can be facilitated by really just options. And when we get into, I don't know if I have the slide on this presentation, but the Alumicor group is part of an Apogee group, and MGM is a partner of ours. And Alumicor is sister companies with Tube Light, Lion Tech, and EFCO and Wausau Windows. And those catalogs are available to all of our customers through our partnerships as well. So really just a brief little synopsis of what we're offering as a team and as a group. And I think it is different than what most people are offering. Just essentially, I'm breaking down what I just said. we're trying to do a one-stop shop enterprise where you get your engineering expertise, you get your design expertise, you get your fabrication, you get your installation, you get your supply, you get everything you need in one area. Obviously, we have our own window wall system. It's called the Tubelite 950 SG. It's extremely high-end, tested in Canada, tested in the northern United States. MGM is a certified fabricator of them in Canada and across North America. We'd like to be involved. And these services are available to anybody who reaches out to us, anybody who wants to work with us. We are busy as always, but always willing to take on new clients and the right partnerships. I, as a CDM, that is half of my role. I spend 60 to 70% of my time in the architectural community in the Maritimes of Canada and outside of it if I have to, or if that's where I'm pulled. But yeah, MGM specifically, Jason, I'm just going to step on your toes here a little bit and jump in on this. But essentially what they're doing here with their one-stop shop is offering a glass line as well. So not just aluminum curtain wall, window wall, but they also have glass sealed unit lines, tempering ovens, and other offerings that they are including in this package. They fabricate our doors, they glaze our windows, they fabricate all of our products, whether it's ribbon window, window wall, curtain wall, stick, unitized. They're really the experts with us on this stuff. And we are, as a team, willing to work really anywhere in North America. So yeah, this is just, again, our family of products, our offering. This is all available, multiple options for everything in this list. You can reach out to us if window wall is not on the menu for you. All of these things are things that we work with on a day-to-day basis. And we'd be happy to answer any questions about those things as well. Just to give you a brief glimpse of what we were showing you, kind of examples of this in the presentation. This is Alumicor and MGM's, I would say, answer to North America's need for high-end performance window wall systems. Said it earlier that Tubelite 950 SG window wall system. It's a newer system. I think it's about 5 years old, and it just came to Canada about a year or two years ago with MGM. They've done a few projects with it now, and it's been fantastic. It is an excellent product. It's a beefy, heavy product for our northern climate. I think typically with a lot of window wall systems, you see a thinner gauge, you see a little bit more of a ribbon window system. This is a beefy system. Anybody who's been up in Canada, or for any of our architects in Canada, you'll understand why that concerns us as well, or even in Minnesota or any of the other colder states, right? And these are, you might recognize some of these products from our catalogs in the States or from our catalogs in Canada. But with our window wall systems, with that 950 SG, all of our high-end architecturally rated thermal products are easily integratable. They retain their architectural rating. That is great for high buildings over 40 stories that require architecturally rated products. We have architecturally rated punch window, terrace doors, as you see, architecturally rated commercial windows even, and the phantom vents, and obviously the more specialty products that hide the lines and hide the doors and the windows and everything. So really, the one-stop shop option and philosophy has been our philosophy as a group and as a partnership, and we're just expanding that with presentations like this, where we're really trying to clarify what window wall is, get people interested in window wall, and then get them maybe asking us questions about what a modern window wall system can do for a project that they're looking at, and we'd be hoping to jump in and help you guys out with that kind of question. So thank you, and we'll be very willing to take any questions that anybody have right now.
Amazing. Thank you, Cass.
I hope that was helpful. Yeah.
Yes, that was perfect. All right, let's jump into these questions here. First question is, how are field condition tolerances accounted for? Jason,
I'm going to let you answer that.
Field tolerance conditions. We're talking about different substrates, I assume. Given that you have different substrates like concrete, wood, all that good stuff. Basically, you just design your receptor systems to be compatible with that. You can do different strap anchors like we showed earlier. You can do different shimming. You can use no strap anchor. You can just bolt right down through it. I'm assuming that's where the question came from, but there's multiple different anchorings that you can use for every different substrate.
And that's a good point, Jason. Just because you chose an anchoring system at the beginning doesn't mean if you get to site and you find a condition that maybe doesn't allow that, or you find a condition that can be improved by using those, it's not like you need a new receptor for those anchoring systems. They can be adjusted on site, so you can move between those. You can move between those options post order. So that is another good thing to say. There are options, ways to handle those types of site conditions without having to redesign or reorder the entire system. We've run into them. We've run into plenty of them ourselves.
Right. They also come with starter strips as well, so it doesn't have to be a continuous glazing system all the way around the building. You can butt up against wood walls like wood bucking, concrete, and there's different anchors as well for that. You basically start from one side and work your way in a linear fashion.
Gotcha.
Excellent.
All right, thank you. Next question is there any head or sill through wall flashing with this system?
Through wall flashing.
Repeat that again, please.
Is there any head or sill through wall flashing with this system?
Through wall.
Yeah. Can you ask the question asker to define through wall flashing, like through the wall?
Yeah, that's fine. George, feel free to clarify in the Q&A if you'd like. He does have another question in addition to that one. Is there a barrier needed for this system?
Yeah, so basically we use like a membrane, like a peel and stick membrane. So we use like it's a 3M product, and we wrap the curb with that, and you mastic and terminate all the edges of that barrier. So essentially it's like a peel and stick vapor barrier.
Okay, gotcha. Perfect. We'll see if we can get a clarification on the other one. If not, I'm going to keep moving on here. Next, we have what are the instances and advantages where you combine a curtain and window wall system?
Well, the first one that pops into mind, we just answered this question about a week ago, Jason, is when the project has one elevation that's all slab to slab windows, and then the next elevation is all punched windows. And then in that situation, the curtain wall would obviously make an ideal punched window application. And it's such a similar, like they are similar looking anodized products. So you're really not sacrificing. I think what's the sight line on the bottom of the sill, Jason? Is it 3.5 inches on the head on the sill, right? Yeah. So really you can get a pretty similar looking look in a punched window application, which would be far more suitable for a curtain wall window or a punched window, right? However, I did look into this and I did check to see, and engineering did tell me I could use our window wall systems as a punched window application if absolutely necessary. But there are advantages. I mean, there's going to be certain, what would you say that, Jason, there's going to be certain applications where it's maybe not slab to slab. The building design might require, here's another good one, where the building design has a vertical requirement where the curtain wall caps are running past the slab. You might want to switch to a stick-based system for a design like that. We're working on a building right now where most of the building is slab to slab, right, Jay? But the top 3 floors or 4 floors are vertical design, where the vertical back section runs past the slabs about 40 feet up. So there, you'd probably want to switch to curtain wall for an application like that to get that look. Obviously, there's going to be certain designs, but the two systems, again, they can go back and forth. They can be, the looks are very similar. So it's a really applicable thing. You can get quite creative with it. I hope that answers the question, Jay. Any other ideas of when that might happen?
Yeah, I mean, I don't know if they're talking about, having a curtain wall system adjacent to a window wall system and how they marry up together, but haven't really seen that application yet.
Haven't really seen the need for it. I think ideally you'd try to design around that situation where you'd have them both in the same module, but I'm sure there are solutions for that as well. Mm-hmm. That's not something I'd lose any sleep over, that's for sure.
All right. Thank you, guys. And next question is, do you have Revit families available?
Revit, I don't believe we do. That's a program, right? Revit is a pro. I've looked into that. I don't think we do. but I can double check that. I'm going to double check that to be sure. Revit families for 950 SG.
Thank you. All right. Next question is, do you also provide and incorporate movable/folding window wall systems?
Movable/folding window wall systems. I think what they're probably referring to there is like a nanowall system, I suspect. And the answer to that is no.
Gotcha.
No, it's okay. Our system is anybody can reach out. I have samples available. I can ship them to you guys, but it is a beefy system. It's deep, like it was 7 inches deep. Like you're not going to be folding that system up. So it's definitely more designed for performance and for thermal and dead load performance and wind load performance.
Okay, perfect. Okay, and the next question is, you might have covered this, but do you have hurricane/wind rating for Florida or other coastal areas?
Yeah, we do have that available in the United States. I can get that, yeah.
Amazing.
We might even have it for Halifax. I don't know. We got hit with a hurricane 2 years ago. I shouldn't say that. I just moved here.
You never know. Hopefully not. All right. Looks like we have a clarification on that one through wall flashing question. So George says, through wall flashing, any metal flashing system at the head or the sill, or is the system reliant on the sealant only?
The system's reliant on the sealant.
Oh, I see. Yeah. Yeah.
Gotcha. Okay. Thank you, George.
Gotcha. Yeah. Thanks for the clarification.
Okay. Looks like we have one more question. Sorry. Okay. Looks like this person's saying they didn't understand the detail where individual window units meet side by side. It's a butt joint with a silicone seal. You didn't show a plan view of this joint.
Let's see if I can find it here. This one, I think he was talking about. Oh, is he talking about the outside joint?
I'm not sure.
Sorry, can you just read it again? Sorry, now that I have the
Yeah.
picture in front of me.
Yeah, it says they didn't understand the detail where the individual window units meet side by side. It is a butt joint with a silicone seal, question mark.
Well, that's a
Oh,
proprietary
I
gasket
see.
there.
Jason, if you want to explain that, but when they meet side by side, it's not a sealant. It's the vertical gasket that separates them. These click together.
The illustration on the bottom left shows the two panels coming together.
Yeah.
And then the illustration in the middle is an optional aluminum cap.
Yeah, these are 3 options. Yeah.
Wall system. And
I
then
should
the
have explained
illustration
that better.
on
Yeah.
the far right is your termination with your starter strip.
Thank you for explaining that, Jason. Yeah. So this is your typical detail where the modules meet. This is a detail if you want to try and mimic a little bit of a curtain wall look with a cap. This is just like an applicable little strip cap. And this is your termination detail on the wall. Sorry about that. I should have clarified that. Thank you for asking that.
Okay, perfect. Yeah, it seems like they understand. They said, so there's a mullion at every window unit.
Yeah, so
it's half a mullion. Yeah.
Yeah, each
Okay.
jamb of every window section has an open back module mullion, and they're male and female, and they snap together as you progress down the building.
Okay, gotcha.
Similar to a strip window system that way, yeah.
Mhm.
Or a unitized system.
A coupler mullions, more or less.
Okay, thanks for clarifying there.
Excellent.
And it looks like that's the last question for now. So I guess, are there any final notes you two would like to make before we wrap things up today?
No, thank you for your time, everybody. Really appreciate everybody giving us your attention and coming out and showing interest in this. We're available afterwards for emails, phone calls, or I think our information is going to be made available. We've sent lots of samples out. I have lots in my office if you guys would like to have a physical idea of what you're looking at. And if you have questions about any of the other products we mentioned in there or any other aluminum products, we're happy to answer, or design questions, or what do I do at this situation in this project? We're here to help. And that's really the main point we're trying to get across as well. So thank you guys for coming out, and thank you for your time.
Awesome. Yes, thank
you
you.
very much.
And thank you, everyone. Again, if you did fill out the poll, the good news is you will get an email after this connecting you directly with Cass and Jason. So That is a good way to get samples shipped to you. You can share your shipping address, or you can just ask additional questions. So definitely keep an eye on your inbox there for an email connecting you through the Acelab conversation. Otherwise, we thank you all for joining. Thank you for a great presentation, Cass and Jason, and we hope you all have a great rest of your day.
Thank you guys
Thank
very
you.
much.
Thank you.